Hello viewers, welcome to Meteorology. In this video, our main focus is on ozone layer depletion, its causes, its ill effects, and also how to prevent the depletion of ozone layer as undertaken by the Montreal Protocol. So let's get started. Let us first know what does ozone layer depletion mean. The ozone depletion consists of two related events observed since late 1970s. A steady lowering of about 4% in the total amount of ozone in the Earth's atmosphere and a much larger springtime decrease in the stratospheric ozone around the Earth's polar regions. This is referred to as the ozone hole. There are also springtime polar tropospheric ozone depletion events in addition to the stratospheric events. Now, let us know what are the causes for ozone layer depletion. The main causes are the manufactured chemicals, especially the halocarbon refrigerants, solvents, propellants, and foam blowing chlorofluorocarbons and the hydrochlorofluorocarbons. These hydrochlorofluorocarbons are also called as halons. These are all ozone depleting substances. Aerosol sprayers, packaging material like styrofoam rise into the atmosphere, especially in the stratospheric region, by turbulent mixing after being emitted from the troposphere. They mix much faster than the molecules can settle, and that is where the problem begins. Once in stratosphere, they release atoms of halogen group through photo dissociation, and this which further catalyzes the breakdown of ozone into oxygen. When emission of halocarbons increase, ozone depletion randomly increases. The ozone layer is a shield to prevent the passage of harmful ultraviolet light into the Earth's atmosphere. But the reduced ozone cannot prevent its entry. So, these harmful wavelengths cause skin cancers, sunburns, cataracts, sometimes even permanent blindness. This also leads to reduced productivity in the ecosystems, harming plants as well as animals. The Arctic ozone hole, the dramatic increase in the genetic disorders and other such problems with a thinning ozone layer led to the adoption of the Montreal Protocol in 1987. It bans the production of CFCs, HCFCs, and the ODS, that is the chlorofluorocarbon, hydrochlorofluorocarbons, and the ozone depleting substances beyond the CFCs and HCFCs. New refrigerants had to be discovered to replace the old ones. The ban came into effect in the year 1989. The ozone levels started stabilizing by mid 1990s and then began to recover in 2000. The Montreal Protocol is considered the most successful international environmental agreement to date. Following the bans on ODS, the UN projects that under the current regulations, the ozone layer will completely get generated by 2045, approximately 30 years earlier than previously predicted. The Montreal Protocol phases down the consumption and production of different ODS in a stepwise manner with different timetables for developed and developing countries. Both group of countries have binding time targeted and measurable commitments to control the ODS. The Ozone Secretariat is based at UN Environmental Program Headquarters in Nairobi, Kenya. It evolves over time in light of new scientific, technical, and economic developments as it continues to be amended and adjusted from time to time to bring under complete control the ozone layer in both the troposphere as well as stratosphere. Let us try to know a little further about the ozone holes. The Antarctic ozone hole is an area of the Antarctic stratosphere where the ozone levels drop to as low as 33% of their pre 1975 values. The ozone hole occurs during the Antarctic spring, that is, from September to December, creating a polar vortex. Over 50% of the lower stratosphere ozone is destroyed during the Antarctic spring. The polar stratospheric clouds formed during winter are extreme cold. The polar winters are dark, 3 months without any sunlight. The polar vortex traps and chills the air. Temperature hovers around minus 80 degrees centigrade. There are three types of polar stratospheric clouds. The first being the nitric acid trihydrate clouds, which in turn destroy the ozone layer. Most of the chlorine resides in the reservoir compounds, primarily the chlorine nitrates as well as a stable end product such as hydrochloric acid. These end products remove chlorine from the ozone depleting process. The reservoir compounds sequester chlorine can later be made available via absorption of light at wavelengths shorter than 400 nanometers. The nitrogen dioxide is removed from the clouds by denitrification to nitric acid in the polar stratospheric cloud particles. These can then be lost by sedimentation, which prevents freshly formed ClO from being converted back into the chlorine nitrates. So we can summarize that the Montreal Protocol contributes to the sustainable development goals and thus helps to prevent the ozone layer depletion and restoring back the healthy conditions of survival on the surface of the earth and rebuilding of the stratospheric ozone layer. I hope you liked my video. Do not forget to give it a like, share it with your friends who may find it useful, and please do subscribe to my channel if you still haven't done so. Thank you once again.